Welcome to another episode. Today we've got a really epic roundtable discussion. We're going to do a deep dive on Tesla's AI Day, their chip program, and the technology that allows their cars to drive themselves, and eventually the Tesla bot. I'm super excited to have three different guests on. Welcome to the show. Maybe we can start with James and do a quick, just really quick background of who you are and what interests you about Tesla AI Day.
Hey, Gali, thanks for organizing this. I'm James Wang. Probably most folks know me from my time at ARK Invest, where I covered internet and AI. Right now, I've joined a new company. I've joined a crypto company called Amoon, where we're focused on building index products purely on top of the blockchain, ARK for blockchain, if you will. But I still follow AI very closely, and obviously a huge Tesla fan, especially given that they're probably the foremost company in pushing applied artificial intelligence. I watched AI Day with great interest, and I thought it was like the most impressive tech presentation since probably the iPhone for me personally. So I thought we should get together some folks to break it down.
Hi, Gali. Yeah, thanks again for inviting me. It's great to talk about some of these subjects. So a lot of people know me from having been the CEO and co-founder of a company called Nirvana, which was arguably the first AI startup in the hardware space. I actually had an interview with James, a little over a year ago on this topic. Recently, actually, I've started another company that is in stealth at the moment. We'll be coming out soon to talk about what we're doing purely in the software space. It should be interesting. But I've been in the AI field for 15, 17 years, something like that, and before it was called AI in this latest version. And so obviously applications of AI are super interesting and important to me. Transportation and automation in that area is obviously a huge impact on the world, and one of the first impactful applications of AI, I think. Search and other things kind of being accepted for now simply because they fix a company's problem, not the user's problem. So I think this is a really interesting topic, and it was great to see Tesla's AI Day. I think I'm going to look at it a little more of a skeptical eye, maybe, than James, but I think there were some really great announcements there.
Hey, my name is Dylan Patel, and I'm the chief analyst at Semi-Analysis, and I tend to focus on the Tesla AI Day from a semiconductor perspective. I really like to investigate and analyze the semiconductor chip equipment, chemical, the entire supply chain from design, IP firms, especially from an investor angle. So Tesla AI Day was super exciting because they're doing some things on the semiconductor side that have never been seen before on a photonics and packaging perspective. So we'll dive into that later on as well.
Dylan's preview story basically called out the packaging technology used in the Dojo computer. So everyone should check out Dylan's website.
Yeah, that's awesome. It's honestly I feel a little out of my depth with all of you because the presentation was so technical and like nerdy almost that I feel like almost all of it went over my head, other than Tesla has this new chip to train neural nets. So maybe we could kind of start with how the neural net actually works, and this sort of kind of behind the scenes technology that Tesla's been transforming of how to train the cars, of starting with the images, moving to video, and now creating this thing called vector space, which is where the car's brain sort of recreating the world and trying to understand it. So maybe you could help us break that down and sort of what's going on there behind the scenes of the FSD tech.
All right, I'll give my attempt at the layman's version. The fundamental problem Tesla, of course, is trying to solve is to have really good computer vision, meaning for the computer to be able to input raw sensor data, mostly from cameras, and then to make sense of the world. So to actually understand its underlying representation, and then to be able to output a very few control signals, which is basically steering, brake, and acceleration. Those are the only kind of three outputs, right, that we produce as humans to move a car through this complex planet Earth, anywhere where there's roads. So it's a very, very rich data in, very sparse signals out. And you can view it as a kind of a robotics control problem. You can view it as an AI problem. There are many ways of looking at it. The DARPA challenge kicked off this idea that we can build a computer with the software and hardware to do such a thing. Prior to that, it was kind of like science fiction. And out of that DARPA challenge came like projects like Waymo and eventually Tesla. Tesla's approach is unique among all the kind of vendors out there in that they don't use, they basically only rely on cameras or basically vision to make sense of the world. Other companies like Waymo and others will use LiDAR, which uses kind of laser pathfinders. They will use radar. But Tesla basically decided vision is all we need because humans only drive with vision. But this means also their software has to be exceptionally good. It has to solve kind of the problem of being able to infer depth just from looking at a camera. And a camera is no different than the camera on the back of your iPhone. That does not give depth information. It simply records color information in 2D, right? That's why you get a photo back on your phone that's 2D. There's no depth. Where's the depth information? The depth information is actually in your brain. You deduce the 3D information based on what you know about the world. So your brain does the 2D to 3D conversion. Tesla's big kind of like a lot of the segment in the early part of the talk was about how it does that. So first generation computer vision for automotive was all based on kind of this 2D processing, just treating the video like a 2D video and just moving, like you see these bounding boxes moving around. And the big challenge Tesla has been trying to solve is to convert that into a 3D representation, or what they call vector space. And in that, you bet the computer actually like has the underlying data structure is 3D and views everything in 3D. So it knows the relationships and that gets much higher accuracy. So 3D is much more challenging for data to label that kind of data. You have to label it in order for the neural network to learn from it. And it's all a higher process, it requires higher kind of compute performance to train and to process. So it's a huge 2D to 3D is as big of a leap as it sounds, right? It's like dimensions of change. So that's kind of their core problem. And they're still in the midst of solving that problem. That's kind of my version of like the setup.
Yeah, I can add some to that. So I think one thing to give an appreciation to the audience is that a lot of people seem to think that driving a vehicle around is easier than many other robotics problems. And I would argue that it's just as hard. It has all the pieces of a free moving robot in space as any other problem, because the way we actually drive safely, I mean, if you think about the number of interactions we have with a car as a human on the road, it's thousands per trip, and we do it without incident, the vast majority of the time. The way we do that is because there's a lot of priors that we've learned from our own body moving through space. And an autonomous driving system actually has to do that. It has to predict what the intent of other vehicles around it is. It has to actually predict what the possible scenarios of a crash or some kind of problem are, like, continuously. We do this without thinking. And so I think that's what makes this a very hard problem. And honestly, I've said it from the start, actually with Rodney Brooks on this one, like, this is a much harder problem than anyone seemed to want to talk about, including Tesla at the beginning. And it was never going to be solved in a year. It's a 10-year challenge, not a 1-year challenge. And I think that's where we are right now. Now, going into some of the things that Tesla announced here, I think are really, it was really cool for them to crack open the neural network a little bit, if you will, and talk about what they're doing. There's a lot of innovations here. A lot of it's also from the field itself. Kind of going to things that are unique to Tesla, as James said, they've been testing with the user for a long time. And what this gives them is a really big advantage in terms of data. They're able to generate user data sets where the user is inputting actions that are correct in different situations. So they have the sensor space, they have all the sensors coming in, and they have what the user did in those spaces, which is a huge and very meaningful training set. And I would argue one of their biggest advantages. Now, in terms of the problems, mapping to vector space, I mean, this is kind of standard right now. That's kind of what we're trying to do there, is really figure out, what kind of motion is going on around you. Like things that are farther away are not changing as fast. Things that are closer to you are more immediate in the action space. So I think that's really what's happening there, and trying to make sense of it from vision only. So honestly, I think they're ahead largely because of their approach on data and users using their stuff. Now, are they really ahead in autonomous driving? I actually argue that they're not, even though they have that big advantage. What's that?
Not yet, certainly.
Not yet. No, you're right. They very well could be. And I'm never going to bet against. But I'm just saying at this point in time, I'd actually argue that probably a Waymo is ahead of them in terms of sheer autonomy.
So let's hear that argument.
Yeah, I mean, simply because they've been at it a lot longer. They've been through many different approaches using what we could call classical or traditional computer vision, which didn't have quite the same capabilities, and they graduated from there. And so they actually have full autonomy on the roads. They've had it for I don't know, about 2 years in sort of geo-fenced areas, which is actually quite a bit different. Now, people don't know the parlance. There's like 5 different levels of autonomy, we call them. Level 5 being that I get in my car, I hit go to this location, and it's arbitrary and it can go, right? That's like what a human can do. Level 4 is similar, but like basically in geo-fenced or restricted areas. Level 3 is autonomy for a short amount of time. I forget the number. It's like minutes, 2 minutes, something like that. Level 2 is 30 seconds. Level 1 are assists like braking and adaptive cruise control, those sorts of things. So, there's 2 philosophies here. I guess Waymo went for like, we're going to focus on level 5 from day 1. And other companies like Mobileye actually said, we're going to focus on level 1, 2 to 3 to 4, and then eventually to 5. Which is going to win? I don't know. Incrementalism versus, taking that big approach. Who knows? I would say Tesla is actually somewhere in between. They really innovated on the 2-3 boundary, I would say, and they're really trying to leverage that now to get to the 4-5 boundary, which, time will tell. I do think data, I do think processing capabilities in their back end are going to be huge factors in helping them win.
Yeah, I would say that first of all, I think the levels are kind of just bullshit, honestly, because it's like the car either drives itself or it doesn't. Like the levels were just kind of invented by the industry standard. But like to me,
they have technical
super farther behind because it's like either like the data flywheel is the biggest problem, right? And they also have LiDAR. So from like a cost perspective, it's like you're buying these cars that are actually gas cars, then you're putting LiDAR on them and you're paying for every single mile driven. Tesla gets paid for every single mile driven. This is why they have billions of miles, literally collecting like 100x faster than Waymo. So to me, that's like, until you crack the free data flywheel problem, you never even actually have a theoretical shot at autonomy. And Google, which is the leader in AI, that's the reason they're divesting from Waymo before it even happens. And like all of their rollouts keep kind of like, they say we're going to roll out and then it doesn't really happen. And it's in this geofence place. So I was super bullish on Waymo at first. I was like, oh my God, they did launch this taxi program. And then they stopped expanding it. And then Google decided to sell out its stake. So to me, if the leading AI company is deciding to divest from you, that is a strong signal that they don't have confidence that this will actually succeed at all.
I disagree, actually.
Yeah. So
strongly disagree on that. I don't think Google divested them because they don't have confidence. They divested them so they can explore their own business models and do what they need to do. That's a very different reason. I think it's actually they're divesting them because they're ready to go on their own.
It's kind of like pushing your child out the door.
Exactly. Yeah. Push the bird out the nest, I
think it's fair. It's a fair interpretation either way. I guess one way to look at the Google versus Tesla scenarios is maybe there are 2 kind of broad possibilities. One is Google is right, and AI isn't that good, and you need LiDAR, and you need this slow incremental approach from easy city to medium city to hard city, in which case Waymo will have a slow rollout and incrementalism will get you there. And Tesla is wrong, and because it's software, we never solve computer vision to the level required to do it with cameras. The other scenario is Waymo is on a non-scaling path. In other words, their current approach of sensor suite processing will only get them moderately better in Phoenix, but they will never make the leap to San Francisco, to Rome, to Mumbai. And Tesla right now is way behind, but they're on this like S curve of improvement because they have a data flywheel. So those are kind of the 2 broad, like maybe ends of the pole. And I think what's exciting is that in the next few years, we're going to figure out where we land on those 2 solutions.
I really agree. Yeah.
What was interesting was Tesla AI Day 2021. Elon Musk is basically saying 2019 Elon Musk was completely wrong, right? 2019 Elon Musk was like, oh, we're going to solve this in a year. We're going to have robotaxis rolled out, machine learning problem. We got this. And all like half of the presentation was, hey, we had to do this differently, right? We can't use 2D. We have to use 3D. Oh, we can't just have the model, predict everything, right? We have to bake in time states. explicitly, oh, you know, we got vision and perception played out, but he himself said that he thinks planning, during the Q&A, he said he thinks planning could do better than the planning not being a machine learning model could do better than a machine learning model, and reach self-driving faster, right? And explicitly talked about the march of the nines, right? You got to get a self-driving car, you got to have, you know, 99.99999, and maybe Tesla's at 99.99. And he explicitly said each nine is an order of magnitude more difficult.
Yeah.
So I don't think he's nowhere. He's not on that, you know, oh, we're going to get this next year. I don't think
he
he's on
was.
that.
No, I was saying that to disabuse people of the original notion that it was never going to be that. I mean, I think in 2016, I laid down the number for a level 4 usable autonomous service to be, you know, 2028, where we can really trust it. And I think that's still about right. It's not going to be that much faster than that.
It's interesting. So you say 2028 for any usable level 4 service, but you've got Waymo rolling out in multiple cities. You've got Mobileye showing off crazy cool stuff in New York, and then you've got, you know, from the other perspective as well. You think no one's going to launch a taxi service that's usable until then?
No.
Wow.
James.
Okay.
Phoenix as like a theme park, basically.
Yeah. The geofence routes they have are the easy ones, right? So it's great. No, I mean, don't get me wrong. Like, they have the infrastructure to like get a whole taxi service over. You can call it, it picks you up, but it's very stereotyped, and it works on certain routes and not on others. So I think there's a long way to go from that. And, you know, the demos, I mean, look, I think Mobileye has done some really interesting work. They're also actually just vision based, by the way. They do use LiDAR, but they use it as a secondary backup system. So they are doing a similar kind of thing. And I think they have the data flywheel issue. They actually have interesting ways of doing it, where they had a device which does lane keeping, and they use that for data gathering and stuff like that. So they have some interesting things there, and they might actually come out, you know, they're on a steep S curve as well. So maybe they'll do it, but they really were about level 2, 3 kind of stuff for a long time. So similar approach to Tesla, but yeah, it's just to get everything to a point where you're not having crashes often, right? When you have no human driver in the car, it's at least 2028.
Yeah, I'm loving this discussion, by the way. And I kind of agree with you on that, because it's like with the FSD beta, it's just, I've noticed that like I love it and I use it and it's such a cool feature, but it's like if I'm actually going somewhere, I never use it. Like autopilot is amazing on the highway. For there, it's a true game changer for like my user experience. But like FSD beta, at least like I'm in Seattle, which I think is a really tough place, because like all these really tiny roads, like everything's weird. Like there's no stoplights a lot of the time, but it's just like it's just like I'm constantly disengaging and like feel like I'm watching like a 14-year-old drive. And so it kind of stresses me out. And I'm watching the improvements, which are amazing. So I'm like, on one hand, I'm like just blown away that it can even do what it do, and that they let it in the wild, and that it's working. Like, I think that's incredible. But on the other hand, I'm like, till this is actually solved, like, and this is what I want. My question is kind of like, when do we see that exponential, you know, the data is exponential, and Elon Musk keeps talking about this rate of exponential improvement, but I feel like in practice, we haven't seen that yet. It's been more of a linear improvement. And so I wonder what your take is on that, and how, if that will, you know, because it's like easy in theory to say that, but I wonder why in practice it hasn't actually happened. Do you have any opinions on that?
It is exponential. Let's just be clear. Like, those linear perceptions take exponential engineering. Each one of like you said, each one of those zeros knocked off is 10x or more effort than the previous one. So it's actually like an incredible amount of effort to keep getting better and better at this, right? So I think that's probably one explanation here, is that computing power, data sets, all of that stuff has gotten bigger, and we eke out this little tiny thing that almost seems meaningless to a user, but it takes it over the line from it was completely useless to now it actually has some value. And later it's going to continue to increase. So we're going to see a linear increase in value, which is actually an exponential or even super exponential in the back end.
I think it's just that humans experience it on such a tiny slice of the timeline. So if you take a tiny slice of an exponential, it looks linear. That's, I think, why it is.
And yeah, driving on a highway is what, 80% of your driving miles. So knocking that out is like, oh, wow, 80% is done. But now, you know, at each percent, it's like impossible.
I mean, the killer app for me, I have a Tesla as well. And it's been sitting in traffic, right? I pop it into auto drive and it's like, okay, I can like do other stuff because I'm not engaged, right? And I'm not going to hit anything any speed. So I think that's what they've done, is I think has been great, has, you know, take away these little things, highway driving, traffic driving, little things like that, and slowly build our way up. But it's still a little ways off, you know.
And okay, so moving on to the Dojo chip, this is really, really cool. So what you were talking about with moving to the video and needing sort of a new way to process all of that data on the back end, it sounds like, you know, this is like a forcing function for innovation, and Tesla's built this in-house chip team to be able to process all of that data that's happening. So that's about all that I understand. Like, they have this chip called Dojo that's like can do all this crazy stuff that's specifically designed for the AI. So maybe we could start at a really high level of breaking that down. Like, why did they need it? And why is it important for the development of their FSD?
I think the most interesting thing is people say, you know, Tesla's has their own chip, but right now they have the largest deployment that's publicly stated of NVIDIA GPUs. They said that their supercomputer would be the 5th largest in the world if they ran the supercomputer benchmark LinPack on it. So clearly they need, you know, tons of AI power. And what really the number one way to think about why they built this chip is because to scale to the largest models possible, the bandwidth between each chip is sort of the limiting factor. And that's sort of the lens that you want to think about for what their system design and chip design is how can we make each chip not seem like an individual chip, but more of a homogeneous mesh that, you know, you can scale AI applications and networks on over.
Yes and no. I think that's true to some degree. I don't think their whole deployment is going to run one neural network. That's either it's not practical, and it's not practical from the perspective of the computing to do that. Also, if you built a neural network that big, you couldn't run it in real time in a car. So that's the other part of it. But I think the bigger thing is actually, you know, large-ish and continually larger neural networks, but being able to explore more of that data space, because as we've been talking about, they have this great data flywheel, but like, I guarantee you they can't churn through it right now. I would put $100,000 bet down on that, simply because it's too expensive to do. And you see it all the time. Like, you look at GPT-3, they can't go through all the data they have. OpenAI has huge resources. They simply can't do it. It's just, it's data and compute limited, or it's not data limited, it's compute limited on the data set. So I think that's the bigger thing here, is that the more they can do it with you know, capturing the cost, capturing the compute at cost from TSMC, and just churn through more data and get better and better.
Naveen, you built the first AI accelerated chip company. You did the math on this, right? Like, does it make, if you're Elon's shoes, does it make sense to spin up a chip design team and the whole like infrastructure, and then relationship with TSMC, and actually buy wafers and chips and memory and all this other stuff? Does that make sense versus just buying from NVIDIA? Like, yes, NVIDIA has a markup, but, you know, is the markup worth all the other trouble?
No. I mean, honestly, I don't actually see the point, because I mean, I can just give people the numbers, right? I mean, to build a 7-nanometer chip that's reticle limit, or a big chip, you know, the mass costs and design are at least $50 million, probably a little bit more, but let's say $50 million. They also have some interesting packaging, which is another, let's say $20 million to make it work. Then software will be at least double that. So you're north of $120 million just to get the system to work. And it's going to take 2 years before that system is useful. Let's be really clear. Just building the thing is not enough. It's the software that makes it hard. And I'm being actually very aggressive when I say 2 years to make it usable. I mean, Google has been at it with TPU for 6 years now, and I think their software stack is still quite immature. So, and there are no slouches. So let's give it 2 years. And, you know, you put in $140 million. You know, how many NVIDIA A100s can you buy? Because this thing, honestly, I wasn't that impressed with the specs compared to an A100. It's like, a little bit more.
Right? It's like basically on par. It's not
on
like
par. Yeah. Because physics are physics, right? That's what people don't seem to understand, is that chips are based on physics, and they're all building on the same physical substrate. And you get what you get, right? The numbers, I honestly wasn't blown away by them. I was like, okay. You know?
I guess if you had to speculate, why did Elon greenlit such a project?
I mean, control, I think, is part of it. I mean, I understand this as an engineer, right? Like, you want to control your stack. You know, not invented here is a strong thing. And maybe you have some customization, right? You can do some stuff that makes it vastly more efficient. In the end, if this continues for 5-6 years, they might amortize that initial build cost and actually do this cheaper, right, than buying NVIDIA. Because NVIDIA has on an A100 has like a 70 or 80% markup, right? So if you can take that away and amortize that savings.
At the same time, I feel like that can't be the reason. It can't just be to save $50 million, right? Because to Tesla, that's nothing in the grand scheme of things. It has to be a strategic reason, which is almost like a 0-to-1 scenario. If we do this, we'll be able to achieve a certain outcome. If we don't, we simply can't get there. That's the only way to think this is important enough.
And that's the part I just don't see. And I mean, I think about this problem all the time. And I mean, I look at the capabilities of this, and I mean, I'll tell you, like, if you want to go for a bigger jump, they should have done what Cerebras did. Yeah. The Dojo is less than Cerebras. CS2 is better in every dimension.
Dylan, you should help us break down, like, what is Cerebras? What is the approach that Dojo took, and what do you think of the difference?
Yeah, so I mean, just going back for a few seconds, I think that Tesla's entire valuation is built upon them reaching robotaxis before anyone else, right? It's a $1 trillion company if they reach it before anyone else. And if they don't reach it first, if Mobileye or Google deploy it at scale before them, Tesla is tremendously overvalued, in my opinion, right? That's simply my opinion. But in terms of
battery business too.
Yeah, I mean, the Chinese firms are commoditizing that like crazy, but yeah, we'll see. Anyways, so the chip itself is unusable in a single chip form. I don't think you can package it even in a single chip form. What they've done is they've built this with TSMC, their partner for manufacturing it and packaging it, has this system called integrated fan out system on wafer, where they take chips that they've produced that are good, and then they package them on top of basically a wafer. Not necessarily, but what that does is it allows them to have tremendous bandwidth out of each chip, and connect each chip to each other at a tremendously high bandwidth, right? Higher bandwidth than NVIDIA can connect GPUs together.
Question on this: when you do chip on wafer, is that bandwidth the same as if it's on the same chip?
No.
I wouldn't necessarily say that, because on chip, NVIDIA's claimed multiple tens of terabytes per second, whereas maybe even hundreds for their network on chip. But Tesla's talking about 4 terabytes or 8 terabytes a second off of the chip. So this is still an order of magnitude above what NVIDIA can do.
I disagree.
GPU.
I disagree, because the what I was getting at compared to Cerebras is they went with a SerDes-based system. I'm pretty certain. SerDes is SerDes, right? I mean, you can do short reach SerDes. They're using 112. Sorry, yes. SerDes are high-speed serial links. So they're sort of a standard IP for using a SerDes. 112 gig is the state of the art right now. 112 gig per lane, and you gang them as 4 or 8, so you get 112 gigabytes per 8 lanes, and that's all they're using. See, this is not that impressive to me, because it's short reach, meaning that you can only go short distances. Which cool, you can do that because it's on one die or one wafer. But that's not really using the wafer packaging. And CS2 from Cerebras actually use the wafer packaging. They're using metal layers across the top and not bound by SerDes. So I disagree that an NVIDIA GPU can't do this. They chose not to do it for various reasons, because the bandwidth's not there. And there's actually a lot of practical concerns around doing it.
Is this faster than MCM style, multi-chip module kind of style packaging?
No. This is a multi-chip module essentially.
Then what's the what's the big deal with the integrated fan out? Like, what is new about this packaging mechanism if it's the same performance as decade-old MCMs?
It doesn't have to be the same performance. So the way they're doing it is like that. So I would argue that Cerebras is also a info type thing. But it's using a different way of communicating across. They're using actual metal layers across the chips. So their highest metal layer connects the chips directly, whereas these guys are using standard SerDes to talk, what's the advantage?
I mean, I don't know it at this level, but my conceptual understanding for people who are not deep in the electrical engineering is these, like, if you think about the microprocessors you have for any device, right? There are little wires inside, right? And it's fast when the wires are inside. It's slow when the wires come outside. And when you look at that green board and you can see wires, those are slow wires. The wires inside the plastic cap of the chip that you can't see, those are like nanometers thin, those are fast wires. So basically, for high performance, you want to use the fast wires, or the metal layers, as Naveen's calling it, not the wires on the outside, which are like these physical, really fat ass wires, right? And we're trying to figure out, does Tesla use the big wires or the small wires?
So the advantage of using this, wafer thing, even with SerDes, is that multi-chip packages can't go this big yet. So you can't put that many chips within one big package. And there's a lot of reasons for that. I mean, some of it's power delivery and other things, but that's what this really does, is allow you to have physical distance closer for all these chips. Now, why does physical distance matter? We're all still up against the speed of light. So a signal propagates at, it takes about, at the speed of light, it takes about, I think per foot, it's like 1 nanosecond. So, a nanosecond seems like a very small amount, but when you're running at a gigahertz, that's 1 cycle. So, you're basically talking about cycles between different chips. And when you put them physically close to each other, you can reduce latency. Latency is actually your big killer here. And this is the advantage, is that when you're trying to do what we call an all reduce, which basically says, I'm doing a matrix multiplication across a bunch of different chips, and I want to collect all that information together. You basically have a communication across the entire fabric to everybody. And when you do that, latency is your dominating factor. That's what actually decreases your total time of being able to do all reduces, or to do the communication of an all reduce. So, and that's a fundamental operation in a neural network. And so reducing latency allows you to do more of these faster. And that's why being close is a good thing.
So I do want to push back a little bit on saying Cerberus is better in every perspective. Within the wafer, yes, their single, WSE2 is better than a 25 chip tile from Tesla, but Cerberus doesn't have off tile bandwidth that's really, breathtaking.
Sure. You're right.
And NVIDIA, same way, right? They can do a bunch of SerDes, but the SerDes have to be on the edge of the die, right? So you have a die, and on the edges of it, you stick the SerDes. Well, NVIDIA dedicates some of that area to memory, some of that area to PCIe, some of that area to the SerDes for NVLink, which is their proprietary interconnect.
Yeah.
But Tesla does all of the area for these SerDes and nothing else. And so that lets them, scale up to a higher bandwidth.
That's not entirely true. I mean, so I think so you have to have some kind of PCI or control plane. And the Tesla chips, they didn't really talk about that, but it's got to have something. There's got to be something where they connect.
So on the wafer, on the system on wafer, they packaged separate control chips that connect to the host system.
Sure, but those control chips have to connect to all the other chips. So there's definitely going to be what we call shoreline, like the edge of the chip, devoted to that kind of thing. I don't think there's any strict advantage to doing it that way. And also, I mean, they basically have northeast, southwest, right? The 4 edges of the chip have connections outward. It's standard. We had this at Nirvana. It was a pretty normal way to do things. I don't think there's anything groundbreaking here is what I'm getting at. NVIDIA could add more SerDes, but it's more power, right? There's also a lot of other things with like, encryption and all this kind of stuff if you want to talk about a cloud environment. So that's what NVIDIA is dealing with. I don't think there's anything groundbreaking on the way they did it here. You are right, though, they have more off-tile bandwidth than Cerebras.
And to be clear, those SerDes and the photonics that they're using to connect between tiles are entirely licensed and produced by another, not produced, but licensed from another chip company. It's not Tesla themselves that are doing the photonics for tile to tile or designing the SerDes that they're putting on this chip.
Correct. Sorry, James, you're going to say something.
Is it fair to say almost like Tesla basically wanted a chip like Cerebras, but the Cerebras to do that is actually really hard. And they went for a easier way to kind of the fastest, dirtiest way to kind of achieve a Cerebras-like architecture without the intertile thing.
Yeah, I mean, perhaps. And I think that's fine. But I think, personally, if I were there, I would have chosen probably not to do this and to just figure out how to make an NVIDIA chip do what I needed to do, because there's a ton of bandwidth. Like most of the packages out there don't know even how to utilize the bandwidth on an A100 now. And again, I think NVIDIA has been very smart about kind of ratcheting up their capabilities as the community is ready for it. Now, of course, these guys are building, Tesla's building for themselves and not building for Tesla, and maybe they can go a little bit faster. And so that's the possible advantage. But I would be very surprised if they can use any of these capabilities in 2 years. Personally, I mean, it's just so hard, right, from a software and algorithm standpoint. In 5 years, certainly, but by that time, I think NVIDIA is going to be pretty darn close.
Naveen, I wanted to ask you a question about this actually. So the biggest criticism I had for this chip was they have this mesh and they have no external memory, and they have SRAM on die. So they have each functional unit within the chip, right? There's 500 or so functional units. Each of those is a teraflop of floating point 16, but they only have 1.25 megabytes of SRAM. So sort of the amount of flops is really high, but the memory for that flop seems low from my perspective. What did you think about that?
I think you're absolutely right. I mean, it's a physical issue, right? I mean, memory takes up a certain amount of space on a chip, and their chip size I think was 645 square millimeters. Just for people's reference, that's a pretty big chip. The biggest you can go is actually what NVIDIA has done, about 840 square millimeters, something like that. That's the absolute biggest you can build. And in fact, only NVIDIA could do that. I doubt these guys even have the capability, but the memory is a big challenge. And what that does is it basically makes it extremely difficult to distribute neural networks. And this is exactly the problem that Cerebras has, exactly the problem that GraphCore has. So again, that's why I'm saying this is not like some kind of game changer. There's a lot of work that needs to be done to make this actually usable.
And they pretty much flat out admitted, like one question in the Q&A was, have you solved the workload partition problem, which is how do you spread the big neural net across all the chips? And the guy's like, we haven't, but we will. That was the answer.
I mean, Cerebras and GraphCore are doing that work. They've been at it for a little while, and I think they're going to be a couple of years ahead. It's just not an easy problem.
Golly. Are you still following? Have we lost you completely?
No, I mean, I'm it's awesome. It's a little bit lost me, but it sounds like the gist of is okay. I think it's, first of all, Tesla built this chip team in-house, which is epic. And whether they got better than NVIDIA or the status quo, it sounds like it's up for debate. And there's a lot of nuance to that. But I think it's already impressive that they're in that conversation already. And then I guess my super simplistic question is, because they're designing this for the specific application of what they need it for, is there any advantage to that, of where they're like, we want to optimize for super low power consumption and this type of neural net training that we really need, versus buying an off-the-shelf solution which isn't tailor-made to exactly what they want? Is there something to that angle?
A little. I mean, honestly, I think the neural network approaches change, and every year or so there's usually a pretty big shift in how things are done. And they were smart enough to build this in a general way. From what I can tell, it looks like relatively standard generalized AI compute, meaning that it could handle any variety of different types of neural network approaches, which is smart. You don't want to build a piece of hardware it's not going to be ready to be usable for 2 years, and then in 2 years all of a sudden everything shifted and it doesn't work. You can't make it so specific, right? So they did it the smart way, which I don't think there's any really huge architectural advantage that they have from a programming standpoint over like an NVIDIA GPU.
And maybe even tying into that for your answers, the whole AI training as a service thing, because I know the Tesla investor community is really excited about that potential. And Elon's hinted about it on a conference call, is like, this turns into some sort of AWS like competitor, but next level, where we can do AI training as a service for other people's neural nets. So when you say it's sort of general, maybe that's the case. Like, when you hear about that, I'm just curious, like, is that an industry that's going to be huge in general? And then, what's Tesla's shot in that industry with this Dojo computer?
I mean, yes, it's going to be huge. You'll understand why I say that very soon, but that's going to be a huge area. Is this going to help them with that? I don't know. I mean, again, look at the TPU from Google. And I think Google has some of the best engineers in the world, and they built a thing that was state of the art. And still they struggle, right? They still, my guess would be they sell more A100s in Google Cloud than they do TPU compute.
Certainly.
So, I mean, the A100 being the NVIDIA part. So, they've been at it for 6 years. This is a hard problem. And NVIDIA has actually been at it for 15 years. if you think about it, like with CUDA and stuff like that. So I mean, honestly, the first version of CUDA was awful. It was absolutely horrible. I used it, and and that's okay. That's what happens, right? It took 15 years, and now it's sort of mature and kind of works, right? So,
Gally, I would, I think it's like getting Dojo useful for Tesla internal is like first level boss.
yeah.
Making their money, making it right now clearly, if they stop the project in 5 years, before 5 years, is clearly like a loss versus just buying NVIDIA, because that would have been cheaper and simpler, less headache anyway. So getting to point of like being net positive investment wise versus just buying NVIDIA stuff is like level 2 boss, and that's probably like 5 years away at least. Like the next level boss, like level 3 boss, is selling this as a service to other people. Like it is three levels harder than everything we've discussed up to this point. And not only is it harder in just like pure hardness terms, it also requires a complete mindset change for Tesla as a company and as how it serves its customers that it has never ever demonstrated. For example, Apple, for example, is a fantastic business to consumer company, right? But every time they've tried to be a service organization, they've been terrible at it. It's just a complete different DNA. Why has AWS, a company that started selling books, won the global cloud computing market when Google is the company that invented, hyperscale computing and search, right? Because they had this complete different cultural mindset, which is we're going to build stuff to service other organizations. And to do that, you have to make certain really hard decisions, like saying, for example, like there's this very famous memo going around of early days AWS, where Jeff Bezos says, you're not allowed, Amazon internal team, like the Amazon team, you're not allowed to use our compute infrastructure, okay? You're only allowed to use our computer infrastructure through AWS as a customer. So he basically forced Amazon's own people to like be a customer of their own company. That way they really dog food it. So if something doesn't work, it breaks their core business. And through all kinds of shenanigans like that and decades of like forcing, AWS became the best like cloud. Is Tesla going to do that? Like, is Elon going to treat GM as a first order customer to itself? There's so many steps along the way. And in addition to building out the software infrastructure, which, as Naveen said, is like a decade-long project. The chips, like Jensen's best quote, I think, is, without software, chips are just sand. They don't do anything. So you have to build the software to make the neural network go into all the chips and fly and dance and talk to each other and use the memory and not leak and all that other stuff. So I think it's like such a long shot, and I would be shocked if they actually pulled that off.
You can almost drive this to similar to how, Intel's trying to manufacture chips for other people. You can make the same allegory here, right? Tesla's only ever had an internal customer, right? You can't even repair your car at a service provider that's a third party, right? You have to go through the Tesla service network, and that lets them do things that are great. And some things are headaches because of that, right? And it's the same concept here with the software. They've only ever, worked for themselves. So when you have all of a sudden you go from, this narrow set of use cases to use cases that can be, infinitely different and, infinitely different cultures trying to use those services, it's just so difficult. So it's possible for sure, right? Microsoft had a culture shift and now is number 2 in cloud and is, catching up in market share, but it required a massive culture shift.
And this is actually an interesting point by why building your own is actually not always such a great idea, because the community uses NVIDIA GPUs. So if some new technique comes out there, Tesla's going to want to use it. They have to go do all the heavy lifting to make it work on their infrastructure, because it's all bespoke. Like you can't rely on anyone else anymore because no one else uses your stuff. And that's always the challenge. That's the challenge for all these AI chip companies too, is that they have to go and implement everything. I've been there. Like we had teams of 150 people doing exactly that work, and it's hard and it's expensive.
So maybe we could really quickly go around and say when you think the first truly self-driving robotaxi will launch and which company, because I think that's just fun. I can go first. I think it'll be Tesla, obviously, in like 2027.
I don't know about robotaxi, but in the form of Tesla's own form factor for their own, like basically for Tesla owners to use. I'd say maybe in the 2025 timeframe.
I'm gonna go Waymo 2028.
I'm gonna go with, in terms of across the whole US, probably 2030 and no idea who, but in terms of like New York City as a whole, I think Mobileye in 2025.
Okay, so I guess we should just preface, like, we're all talking about really hard cities, not like cartoon cities like Phoenix.
Right. Yes. Real self-driving.
Awesome. Okay. And before we go, I really want to get your take on the Tesla bot, just because that's so epic. And I mean, I guess we all kind of knew that sci-fi was going to be reality, but then seeing the Tesla bot was just kind of like, whoa. And now I've been thinking about all the stuff my Tesla bot can do. And obviously, if, we're skeptical that Tesla will, some of you, that Tesla will achieve self-driving at all, obviously, maybe you're even more skeptical of the Tesla bot. But I love this as an idea and as a concept. And so do you have any takes on like how hard this is going to be, or what your thoughts are on this? Because to me, it seems like whether it's Tesla or not, and what year it is a question, but will this be inevitability of we will have these humanoid robots walking around? Like, I know Amazon was working on a walking, moving version of Alexa a couple of years ago. So this is something that's like they're going to work on, that's going to happen. And so I'm just really curious to get your first impression on the Tesla bot.
Let me give a quick preface before everyone starts talking about opinions. I just want to like set a stage here, because Toyota has been building robots and Honda has been building robots for 30 years. Okay, this is not a new concept. Like, I know when Elon says it, everyone gets very excited, but like car companies have been doing robots for a long, long time.
Not in this form factor, though.
Well, okay. I mean, they have humanoid robots, right? I mean, like they
Hyundai,
have.
I remember, yeah.
And Hyundai now bought Boston Dynamics. But so that is not a new concept. But I also will say that solving the autonomous problem in a car, as I said before, does encapsulate a lot of the problems that robotics does. And so if you can really crack some of these things on a control theory basis, you can actually make, I think there is some carryover to robots. So that is well-founded in my view.
Yeah, I agree. I think the logic to do this from an inside out perspective for Tesla is pretty clear. To solve a humanoid robot, you need good computer vision and understanding with your environment. And the Tesla vehicle is kind of like their first version of doing that. It solves a good bunch of that of those problems. And to do this, you need a great neural network and all the training backend and of course local inferencing to support that. And Tesla's semi team, I think they're probably like, okay, that team is gonna support this as well. So it makes even more sense. So that's why they're building it. Where it breaks, I think, is if Tesla succeeds in AV, in autonomous vehicles, it would have done so on the back of its like super rich deployed data set, right? And their deployed base of robots is zero. There's no use case for robots. There's no such thing as a human-driven robot around the house, right? So there is no bootstrap mechanism for them to acquire data just like passively day by day by day. So everything you learn about how to drive in Cupertino and San Francisco does not translate into moving a robot in your kitchen, like from your kitchen to your bathroom. You don't have data sets on stairs. You don't have data sets on like tiles. You don't have anything of that. So to me, the biggest question for the robot is how do you solve the kind of data bootstrapping problem? And can you sell a minimally useful product as version 1 to start gathering that data set?
With the cars, they had this strategy of super high end and then moving down slowly. And they also had more of a targeted market for where they started off with self-driving, right? Highway traffic, and then moving slowly to full autonomy. I don't as James said, where do they bootstrap this data, right? Why aren't they going to deploy a robot that's useful for 1 or 2 tasks, rather than just broadly saying we can do anything with this robot? I would like to hear more about where they want to implement it first. Maybe it is a robot in a factory that does a handful of specific tasks or whatever it is, right? But going from nothing to a full robot with 10 fingers and this human method of walking, which is more difficult than just like a moped, maybe, right? Wheels for a moped. There's so many problems that they're running into at once. How can they break this up into something that's solvable? That isn't just like 10-year out vaporware.
I will say, I mean, there is a playbook here that they could potentially leverage, right? What they did with cars, as you said, was they went with the high end, and they found a demand for something that would pay an extra amount for something new, electric, right? And relatively refined. There was no competitor because all the electric cars of that date were either hobbyists or, you know, something tiny. This was like a nice car that I could drive around that was electric, and I'm paying double or 3x for it. So they found that market. And in the robot space, I think there is this big problem where the people who make the physical robots are actually quite distinct from the ones that do the control. And there is no good integrated solutions out there that do like, here's a robot package I can buy and I can train it up for different tasks. Like there really isn't such a thing. I mean, there's an ecosystem trying to develop, but if they come in with one package and say, here's a slick robot, not a humanoid, something that does some kind of task, makes drinks, something like that, people are willing to pay 5x for, and they can actually leverage that as a data platform like they did with cars. They could have something here, especially when they have the ability to do all the AI stuff in the background with their infrastructure.
Yeah, that's awesome. Well, thank you all so much for the time. This was an epic discussion. I learned so much, so I really appreciate it. And I guess what I will say at the end, what gives me the most confidence knowing nothing about the technology is pace of innovation and give a shit factor. I think Tesla wins on both of those. And I think this AI Day accomplished the goal of getting people super stoked. You know, the robot's really far out there, but like it's inspiring and you want to work there. They move fast. And I just think that is what it's going to boil down to, especially when we're thinking so long term. So like that's what gives me the confidence. Like Elon Musk is just such a powerful figure, driving such a fast pace of innovation, hiring so many cool people with just such a like crunch on the timeline that I think none of these other companies really have. That like I just think that's a unique factor that can't be replicated, but it's going to be epic to follow. So if you guys, maybe you can leave us like where to follow you or what you're working on next with your sign off or any final thoughts. That would be awesome.
Sure. Hey, Gali, thanks for organizing this. And it's been a great discussion with everyone. I agree, by the way, completely. I think the Elon factor, like the Steve Jobs factor back in his prime, can't be underestimated. And, you know, whenever people ask me, why do they build all this stuff in-house? It's like, I give them I worked at NVIDIA and I know what it's like to work with a vendor, right? You have a game studio who has a bug with your drivers. They email you, they send a bunch of stuff to you, and then you work on it. And then 3 weeks later, maybe you send something back. The latency between companies is weeks and months to get stuff fixed. Whereas if Tesla has a bug and they want something like fixed in terms of like to make the software optimize like some piece of code, they can literally like yell at the person next to them, and maybe the fix will be rolled out that same afternoon. So that iteration cycle, AI is all about iteration cycles. I think that iteration cycle in the ideal world can be really fast. So I really am looking forward to seeing what they do. I joined Amoon, and right now we're working on building kind of next generation investing products on the blockchain. I think it's extremely exciting. I think crypto has really woken up and gone from like nerds to reality and with real like useful things you can do for everyday people now. I wrote a blog called 5 Useful Things Crypto Can Actually Do in 2021. You can check it out. You can follow me or Amoon on Twitter, and I think that's a great way to kind of keep up to speed on what we're building and what kind of products we have on offering.
Yeah, thanks, Gali, for having us on today. It was a lot of fun. I could keep talking about this for hours because it's just what I think about. I do have some interesting things coming up on the pipeline, like I mentioned at the beginning, in the AI space, of course, but I think we're actually at another precipice of technology in terms of how we use hardware effectively, how we actually learn from data more effectively. And stay tuned for that. People can follow me on Twitter. I typically announce everything there, and various musings. So I'm at Naveen G Rao.
Yeah, and I want to thank you for having me on as well. It was a very interesting discussion, and we had some very interesting perspectives as well that were from different backgrounds. You can follow. I'm chief analyst of Semi Analysis. We focus on semiconductors from an investing perspective and a supply chain perspective. So a very hot topic this year, but we've been doing it for a while. So you can follow me at Dylan522P or go to semianalysis.com if you want to learn more about semiconductors.
Awesome. Thank you, everybody. Signing off. Really appreciate it. Peace.
Thanks, Gali.